Thanks a lot, Craig. Yeah, this is Russ Howe. I'm Territory Manager, Western New York, Western Pennsylvania, parts of Ohio, parts of West Virginia. I think that's how Hollis and I got hooked up. So thank you for having us tonight. Weyerhaeuser Truss Joist, we're based out of Seattle. That's where our headquarters are. We're all across North America. And it's going to be a little awkward tonight because Craig's driving the slides, so I'm going to have to tell him to advance the slides for me. So, Craig, if you could go to the next slide. And we're going to talk about engineered wood products and, mainly floor framing, but we're going to talk about all the different types and uses. So we got a lot of material to cover in an hour, and hopefully we can get through it and have some time for some Q&A at the end. If we go to the next slide, we'll kind of see the agenda. And, as far as safety goes, safety is really a core value at Weyerhaeuser. We're focused on ensuring the health and safety of our employees and continuing to serve our customers and doing our part to help prevent the spread of the virus. If you'd like to learn more about our company's response to this pandemic, our company's homepage contains a link to high-level COVID-19 information and current actions we're taking across North America. So, just a little word on safety, and then we're going to really talk about floor framing with EWP as engineered wood products, and then, kind of some of the do's and don'ts and what to look for out in the field. And, that's it, the agenda tonight. Let's move to the next slide, Craig. Just some facts on engineered wood. And, really when you look at this, dimensional lumber, solid sawn, you're trying to cut rectangular sections from a round log. I think if you look at evolution of dimensional lumber, you probably only get about 55% conversion of a round log to a structural product when you mill solid sawn lumber. So the beauty of engineered wood is we're either going to peel the log or we strand it. And, that bullet point in the middle says for every 1,000 square foot of floor, it takes 3 trees with dimensional lumber, and with I-joist it only takes 1 tree. So extremely resource efficient material. And I want to say 55% of the home builders in North America today use I-joist. So I see people from all over the country, so I'm sure you look at inspect homes all the time that have them in. Next slide, Craig. And, what does Weyerhaeuser do? We've been planting trees for over 100 years. We're a 120-year-old company. In 2012, we planted 63 million trees. And a lot of folks that aren't in the industry think that, we just cut trees down, but we're replanting them. And actually in the U.S., we have at least the same or more timbered area than we had in 1920. And we practice sustainable forestry practices at Weyerhaeuser. 100% of our timberlands are SFI, Sustainable Forestry Initiative standard. And, another interesting fact is we only harvest between 1% and 3% a year of timber on Weyerhaeuser managed land. So, next slide, Craig. I'm getting a little feedback. I don't know if anybody else hears that. So click it again, Craig. We get asked this question all the time, especially with fire, and we were talking about that earlier. What happens to the glue, and, do they burn faster, et cetera, et cetera. So if you look at typical engineered wood products, it's about 94% wood fiber and 6% adhesive, so it's not as large as you think. The glues are inert, so once they've cured, the fire, they don't react to the fire and just melt. Next slide, Craig. Another thing that we hear is, how does the char rate of engineered wood compare to solid sawn lumber? So what I've done is I've listed some of in the purple highlighted area, the typical engineered wood products that we see, and then a bunch of the different solid sawn lumber species that you may see in your different markets. And you're going to notice for the most part that they're pretty similar. And, you know, what the char rate is, it's the depth of char divided by the measured time is the char rate. Lower the number means slower the burn. However, you're going to see that the char rates are pretty similar. And I think we heard Mike talk earlier, you know, how the wood chars, you know, when we get to 3.5 inch wide lumber and bigger, it really qualifies as heavy timber, the same as solid sawn lumber would, even though it's engineered wood. So, next slide, Craig. So these are the common engineered lumber products that we're going to talk about tonight. We're going to talk about parallel strand lumber, laminated strand lumber, laminated veneer lumber, and then wood I-joist. So the three rectangular products are going to be beam sections used primarily for beams and headers, and then the I-joist is floor joists and roof joists. So we'll start off with LVL. This product's been around since about 1960. You know, it may look a little bit like plywood because we take a log, we peel it to an 1/8 inch thick veneer typically. As opposed to plywood, all the grain goes in a parallel direction. So these billets are 4 foot wide, and really the only you know, the press keeps shoving veneer in, and really we can make it 80 foot long or go to the end of the building. Actually, I think years ago we actually did take the steel off the end of the building and for a stadium project and built some 120 foot long microlam beams. So it's a continuous, for the most part, most manufacturers, it's a continuous manufacturing. It's not a static press. So laminated veneer lumber. You know, another thing to keep in mind is you're going to see LVL from a lot of different manufacturers today. We even see it being shipped from overseas. And the strengths, just because it's LVL doesn't mean the strength is the same, because you know, it depends on the wood basket and the species of wood, so they can vary widely today. Next slide, Craig. And you know, some of the typical uses of laminated veneer lumber.
Hey, Russ.
Did you go to the next slide, Craig? Yeah.
Yeah, we had a question about, and we probably should bring this up now, and I know kind of what they're alluding to, but are there any recalls on any of our prior products that we as home inspectors should be aware of? We had one product called a flak jacket I-joist coating that we were putting on our joist to get a fire rating for our I-joist. And we did kind of recall that product off the market, or remediated product that was in the market, either with a coating that we put over it, or we actually went out and replaced the joist. That is the only product that I'm aware of, unless Russ is aware of something from way back, that we've actually had kind of a recall. I wouldn't know if you actually call it a recall, but we did take it off the market, and that's our I-joist with the flak jacket coating.
And to clarify that, thank you, Craig. It was generation 4. We had a generation 2 that there was no outgassing of formaldehyde. Generation 4, oh, I can't remember the year. I want to say it was maybe December of 16, but the coating was a little bit different. And yeah, we remediated every home in North America that we know of. However, as inspectors, if you go out to the field and you see, you know, some flak jacket, and you had a question, you know, just take a picture and you can go to the Weyerhaeuser website and shoot the picture to tech support, and we'll know. The coatings are a little bit different color. The generation 2 was a dark green color. The generation 4 was a little bit lighter green. And also generation 2 had the coating on one of the flanges. Well, it would have been the bottom flange for the floor. So there was a top and a bottom of that joist. So that's a real good question. No other recalls I know of. You know, if what we do for Q&A at the plant is they're testing product every run. So if something doesn't meet our manufacturing standards for strength, stiffness, shear, moment, you know, compression, all the 6 major engineering values that we're looking at, you know, we pull the whole run. So, and I can honestly tell you that in over 30 years of being associated with Trust Joist products, I can really count on one hand the number of times I've seen bad product in the field. So, moving to the next slide, you know, what are typical applications for LVL? It's going to be for beams and headers, primary structural supports. So you pretty much can't go to a lumberyard in North America today that doesn't stock LVL. Next slide, Craig. As we move on, this is parallel strand lumber, and we call it PSL. And it really starts out the same manufacturing process as LVL. It's a veneer, 1/8 inch thick, but then it's ripped into strands that are, you know, I want to say about 5/8 to 3/4 inches wide. And then these strands are anywhere from 2 feet to 8 feet long. So, you know, when we start to peel a log to a veneer, most logs aren't perfect cylinders. So as you can kind of see in that middle picture, as we peel that log, we don't get full sheets of veneer. And that wood on the outside of the log is pretty high strength. So it's ideal when we start to peel the log, most of that fiber goes into PSL. And then when we start to get full sheets, it goes into LVL. Now you're going to see the picture on the right, that beam is green. So we do manufacture a treated version of PSL, and that's called PSL Plus for treated. So, and that would bring up an interesting point if you go to the next slide, Craig. You know, when you're doing your home inspections, I get asked this question weekly by specifiers, you know, can I use an untreated LVL beam, Russ, for a deck beam and you know, wrap it with, I don't know, ice and water with PVC or something? And our answer is 100% no. We don't want an untreated product wrapped in the field for a deck beam. It's got to be a treated product. So, but I know it happens. Because I get asked that question weekly from specifiers. And our standpoint is absolutely not. So PSL is the only product that we manufacture for exterior use. So you can get it for interior, or you can get the treated version. And once again, it's primary structural supports. The strength is pretty close to LVL, but you know, like all these products, there's not a direct substitution. And when the treated version, we take a couple hits on strength on that, so it's not as strong as the untreated. By hits, I mean we take a hit just for the treating of the lumber, and then we take another hit for the strength depending on the moisture content out in the field, whether it's submerged in the ground or it's a deck beam, etc. So that's PSL. Let's move to the next slide, Craig. I'm not sure if I have a little delay or, and this is going to be laminated strand lumber. So I told you LVL was 1960, PSL was like the 1980s. LSL is probably the most resource efficient engineered wood made. It came around in the early 1990s. And when I say resource efficient, the other products we've been talking about primarily use southern pine or Doug fir. LSL, we can use species like aspen, red maple, you know, essentially weed species in the forest. You cut the forest down and it just regenerates, you know, from what we call root sprouters. And, you know, for the most part, those trees weren't used commercially for any other structural products. It goes through a high steam injection process that makes it a lot stronger than Mother Nature could. Now, if we go to the next slide and you know, what is LSL used for?
Hey, Russ.
It's a wide variety of. Yep.
Hey, Russ, we do have a question on the pressure treated, and they're asking how much treatment on the pressure treated beams. Our beams are basically pressure treated, or if you look at it to what's called a 4A. If you look in the code, it shows you the different numbers and what that particularly means. But there's also deductions that you have to take in design depending on the exposure level, whether it's going to be In a damp environment, I believe it's under 19% moisture content, or between 20 and 28, which would be a typical deck beam. There's a deduction there. And then if you're using it in ground use over 28%, then there's even more of a deduction. So when it is designed, when that product's designed, you would design it for the particular service level that we're using it at. So I hope that kind of answers your question on that.
Yeah, and if you have any questions on the use category, you can visit any of the large treaters' websites. And like Craig said, the PSL treated or PSL plus is use category 4A. So yep. That's important to know. And that actually you can put that in the ground. So
there's another LSL. There's another question here on what is the life expectancy of PSL in a high moisture environment. I'm assuming you mean the pressure treated PSL in a high moisture environment. The regular product should not be used in a high moisture environment, and it probably would not last very long. The treated has the warranty from Woolman on that, and I believe that's what is it, a 30-year warranty, Russ, I think, on Woolman. And then we have a lifetime warranty on any of our other products as long as they're installed properly and used in the right environment. But I'm assuming you mean the exterior PSL, which would have the Woolman 30-year warranty.
Yeah, actually, I think if you read the fine print of our warranty today, it comes with two 30-year warranties, one from the treater and one from us. And then we guarantee against delamination for lifetime. So, but that's a really good question.
Hey Russ, we're still on pressure treated. So in the field, how can you tell the difference between a treated product and a non-treated product? It actually will have the Woolman shield on the treated product. It does have. It used to be a lot easier because the color different. There was a major color difference. The pressure treated had that greenish pressure treated tint to it, and our regular Paralam was very light in color. We've now started to use a kind of a heavy wax finish or a sealer on our Paralam, and it makes the Paralam a little bit darker, so the color's a little bit closer. So you do need to take a look at the label that's on the product, and it will clearly say PSL plus for exterior use. It'll say it right on it, and it will also have the Woolman shield on there where it's Woolmanized. But that is a good question.
Yeah, that's a great question because it would bring up an interesting point that I have come across over the years. Is that builders get creative from time to time, and I've had cases where they couldn't wait, let's say, for lead time, so they sent it to a local treater to be treated. And we don't warranty if that's been done. That would void the warranty. We only would warranty the product as if we treat it because we kiln dry it. We visually inspect every piece before it goes out the door. And but I can tell you that over the years, it's probably happened to me 10 times on deck beams that I've had to look at that were treated by a third party, and we don't warranty any of that.
We have another question that they want to hear a little bit more about the glues that we use in the product. I'll take that one, Russ. The question mentions inert. Basically, what that means is the glues that we use are a phenol formaldehyde base in most of our products. We use some MDI, which is a methyl diisocyanate base too. The formaldehyde is the evaporate, the cyanide is the evaporate, and once the glues are cured, which they're cured before they leave the mill, the glues are actually inert. There's no harmful off-gassing from the products at all. We can't say that they're formaldehyde free because wood itself, natural wood fiber, gives off a little bit of formaldehyde gas. So you can't say that it's free, but the glues themselves will be inert once they're cured. They're also thermosetting. So in the case of a fire, the glues actually get harder. They don't melt, so the product doesn't become unstable. and the glues will actually turn to a powder long after the wood fiber is burned away in the case of a fire. Hopefully that answers some of your questions.
Yeah, and that would bring an additional point. If you're doing an inspection for a house that's been through a fire or a flood for that matter, for the most part, we're going to say that you need to hire a structural engineer. Would have to get involved as a third party because we don't know the temperatures or anything else. When we manufactured the product and it left the plant, it was in good condition. So that would be our answer. I do run into that question a lot out in the field.
We've got another question here that is a good question that always typically comes up. I build large homes that take time to build. How long can your products take the elements of weather before delaminating? TJI-Joist are a concern of mine. Both Russ and I have seen product that have been out in the field for a year. That's been fine, but under typical construction times, the products last fine. You don't want them to be sitting around in water. We don't want to see units of material sitting in puddles. If you're one of those builders that take the time to squeegee off his floor systems after it rains and take care of it that way, I mean, typical construction time for a home, 3 to 6 months is really no issue at all. I don't know, Russ, if you want to expand on that a little bit more.
Yeah, no, that's correct. And the only other thing I'd add is the higher the moisture content of the wood, the weaker it is too. So I want to say for every 2% increase in moisture content, you lose about 1% in strength. So, hopefully they protect the materials the best they can, but,
Another question that might be kind of leaning toward that way, what is the anticipated serviceable life of your products? We have lifetime warranties on our products, but maybe you're pointing more toward the adhesives because I get that question. The basic resorcinol-based adhesives that we use today in our products, they were actually invented in World War II in plywood, to build plywood, to make plywood. And those same basic formulas have been around since then, and they haven't failed. So the adhesives are proven to last a very, very long time. And like we said, we have a lifetime warranty on our products, so we expect the life of our products to be lifetime.
Yeah, which the attorneys say is 50 years, but I can tell you I've inspected homes where they did remodeling that were built in the early 70s. They're absolutely fine. They're just remodeling, and the series and evolution of the products have changed a little bit from time to time, so they couldn't find design tables for them. So let's move to the next slide, Craig. And we'll talk a little bit about laminated strand lumber, just some typical applications. LSL is manufactured in a static process. It's a billet that's 8 foot wide, 64 foot long. Once the billet's been pressed, it essentially goes to another manufacturing plant that resaws that billet in what you see here: headers, beams, engineered wall framing, columns, rim board for the I-joist, stair stringers, and premium lumber for rafters, for floor joists that meet the 2012 IRC code for unfinished basement. Although we probably have folks from 2012, 2015, and 2018 on the call today. So that's one of our answers to the residential IRC code is to use a premium lumber, what we call LSL floor joist, to meet the code today for an unfinished basement. So that's LSL. Let's go to the next slide, Craig. And that's laminated strand lumber. Probably one of the fastest growing segments we see is wall framing with engineered wood. Whether it's going to be a kitchen wall, a bathroom wall, just because they're perfectly straight, but also these tall walls. And I like to just show this picture. Years ago when I first started in the industry, we didn't talk a whole lot about wind and or lateral loads. We were really just looking at vertical loads, and this was pretty typical how a tall wall was framed back then with a hinge in it. but really think of it as a floor joist in a way. Would you put a hinge in the middle of a floor joist span in a 16-foot span? And absolutely not. So, code wants to see these tall walls balloon framing from bottom to top with no hinges. Once you introduce a hinge into it, when we design for these wind and lateral loads today, and some vertical load on there, they don't meet code deflection. So we want to see them balloon framed. But that's probably one of the fastest growing segments we see today for engineered wood. Next slide, Craig. Yeah, here's just a field shot of a tall wall, balloon framed. Typical, two-story foyer. So let's move on to I-joists. I-joists have changed a lot over evolution since they were invented in 1970. Essentially, you have two flanges and a web that just transfers the load from the top to the bottom. And shoot, these I-joists today are made, I want to say, about 200 feet a minute. So let's go to the next slide, Craig. And these are typical applications for an I-joist. Is going to be for a floor joist, and I'm going to call it a roof joist because I-joists in a roof application have to have bearing at both ends. You can't frame them in like a conventionally framed compression roof with a ridge board, collar tie, ceiling joist. With I-joists on a roof, we got to have a bearing wall at both ends, or a bearing wall and a ridge beam, let's say, and possibly I-joists can be used for wind, but I don't see much of that out in the field anymore. And typically it would be just on the parallel gable end non-bearing side. Let's move to the next slide. And I would say when you're doing your inspections, the series, there in 11 and 7/8, as you look at this, just from our product offering, you can get that joist in 4 different series here. The rule of thumb is wider the flange, the stronger the joist is, or if you go to a deeper joist, they're stronger. So, but always consult with the manufacturer if you're doing an inspection. And as we move to the next slide here, you'll see that all the products come with this manufacturing stamp that Craig was talking about earlier, and that's probably the most important information if you're looking at a possible issue out in the field, is that manufacturing stamp. One is going to be product identification, so we know that it came from us. 2 is going to tell us, the mill number, the date and time it was manufactured. It gives us all the information we need right there. So if you're out in the field, just take a picture of that and send it to tech support or Craig and myself, and, we can get the ball rolling if you see an issue.
Yeah, we need a little bit. We need a little bit better picture than that one. That's a little bit blurry.
Yeah, it's kind of funny. I think it's when digital cameras first came out. So let's talk a little bit about floor framing with I-joists and some things to look for out in the field. And we'll go to the next slide. And if you go to the Weyerhaeuser Truss Joist website, you can download any product information that we've talked about tonight in PDF form. We'd like to see our dealers ship this pocket guide that has all the floor framing details for floors and roofs. And we'd like to see it go to every job, whether it's just getting 2 LVLs or it's getting, an I-joist floor. But it has all the framing details, the do's and don'ts in it, and it's a good pocket guide. I think it's available in English, Spanish, and French. Let's move to the next slide, Craig. And so let's just kind of go through. I put this in order of how we would frame a typical floor system, so we want to install dropped and flush beams first. And as we go to the next slide, one of the notes is we want to keep the wood protected from concrete. So we'd like to see a 1/2-inch ear space around and a steel bearing plate. Next slide. And then the question becomes, okay, if I'm connecting multiple plies of an LVL or an LSL, typically you don't see multi-ply PSLs because they're manufactured in wide widths. They come as a one-piece beam. So, the connections are pretty critical. Probably one of the holes are my biggest issue out in the field that I run into, and then connections of beams typically isn't done. So if it's a dropped beam, that means the full joists are going to go over the top of it. We say 3 rows of 10D nails. That .128 is a diameter of the gun nail. That would be a minimum. I mean, typically we see .131 as a standard here. So we say 3 rows of 10D gun nails at 12 on center. Stay 2 inches from the top and the bottom, and alternate the sides at 12 on center. And then for 14-inch and deeper beams, add an extra row of nails. And if you go to a larger nail, like a .148 or larger, you can delete a row of nails. So that's kind of the rule of thumb as far as connecting the multiple plies together on a dropped beam. Let's go to the next slide, Craig. And actually, skip this one, go to the next one. So the connections become a lot more critical. If you see the picture on the right-hand side, we've got a flush beam. So especially if I'm looking at, let's say, assembly F that's on the lower right-hand side, if I have 4 plies, let's say, of 1 3/4 beams, and when you're doing your inspection, we only like to go 4 plies wide. Independent structural engineer could, by all means, if he, because he's the engineer of record, he can go wider if he wants, but we only say 4. And then, but the connections are real critical when you look at this flush beam, especially the picture that's above there. Those joist hangers are only applying load to the 2 outside members. So, there's really no rule of thumb as far as the connection goes, because it depends on the highest load that's applied to the outside member. But if that's a 4-ply beam, that beam has to act as a 1-piece beam, and that's why the connections are pretty critical. And typically what I'm going to say for flush beams, it's typically a bolted or a structural screw connection is what we're going to find today. So really these flush beams have to be designed. There is no just nail it together, fits every application like a drop beam. Next slide, Craig. Just some tips on bearing for beams. We always need full bearing width on a beam. The bearing length minimum is going to be 1.5 inches. However, you're going to find if these beams start to get pretty high reactions, one of the services that we provide for customers in the field is a complete layout drawing, and every beam on there is noted for bearing length. We always assume that they have full bearing width, but length can vary from beam to beam. It depends on the reaction. So next slide, Craig. And then holes in beams. This is probably my second biggest misapplication. My first is going to be holes in I-joists. And, so what we say here, you can kind of look at the beam. It depends on what type of engineered wood product it is. So for the microlam LVL and paralam PSL, that hole zone is only in the middle third of the span and the middle third of the height. And then if you look at the chart over on the right-hand side, it says from 7 1/4 to 20 inch in depth, your maximum round hole size, and that's all we can do is round holes, is a 2-inch round hole. So that's for microlam and paralam. Now for TimberStrand, it has really high shear values, so that hole zone actually is a lot bigger. You only have to be about 8 inches off the bearing, and you can start cutting the holes in the hole zone at TimberStrand LSL. So, a lot of times that's our choice for beams is going to be LSL over PSL or LVL for short span beams that are highly loaded because of those high shear values. And because of that, you can cut larger holes in the beams. So that's kind of I guess what I would say here is the misapplications that I see are going to be from mainly plumbers or electricians running their home runs back to the panel box, and they get outside of that hole zone. So just remember, it's the middle third of the span, middle third of the height, LVL, PSL. It gets a little bit bigger for TimberStrand, LSL. Next slide, Craig. Did you advance the slide?
Sorry, I was on mute. We do have a question on holes. Do the size of the holes add cumulatively? I'm assuming they're asking, can we put more than one hole in there, or not really sure what they're going for with that one. Oh,
well, if that's the case,
can you put 2 1-inch holes? Maybe that's what they're at. Oh, here they go. 2 half-inch holes make a 1-inch hole. That's what they're saying. Can you put multiple smaller holes in, or can you just put one hole in?
Well, that's a good question. I mean, if there's, so we say 2-inch round hole maximum. If you're going to cut an additional hole, you have to double the diameter of the largest hole between the holes. So if we had 2 1-inch holes, we want to have 2 inches between them, essentially.
Correct.
Yep. Let's move to the next slide, Craig. And, you know, as far as notches go, I see a fair amount of these in the field. And if you think of just, you know, craftsmanship is critical here, because the framer's trying to cut a notch with a circular blade that's round, so they overcut them. And we evaluated notches years ago. It doesn't matter if it's on the top or the bottom at the bearing. We don't like notches, so we say they're not allowed. You know, and if you run into them, it's one of them things. You identify the beam and the manufacturer and get a hold of the manufacturer, and you know, we can take a look at it, but we don't like them a whole lot. Next slide, Craig. You know, so let's talk a little bit about why we can cut holes in the web of the joist and I-joist. And if you click it again, Craig, you're going to see, as we, you know, this is a simple span with 2 bearing points. As we apply load to it, the top is in compression and the bottom is in tension. So around the center of the joist is what we call zero stress and bending, and that's why we can, you know, think of it almost like a plated truss you'd see out in the field. You know, there's a lot of open space there. The webs, the top and the bottom cord, you know, is transferring load through the webs that you see. So as we load that joist, and we're going to talk about holes in I-joist and the webs in a minute, it's going to be smaller holes towards the end of the joist at the bearing, because if you think about it, that's maximum shear in the web of the joist, because the bearing's trying to hold the joist up and the joist is pushing down, so it's trying to rip or tear the joist there, and that's where we're going to see smaller holes out in the center of the joist, mid-span. That's where the largest holes can go, around that zero stress and bending. So let's go to the next slide, Craig.
You know, I'm sure Russ is probably going to talk about this, but this slide illustrates it really well. If you look at that bottom flange being in tension, that means it's being pulled apart, and the top flange being in compression, it's being pushed together when this is loaded. So if we get a cut in a top flange, say someone catches it when they're doing radiant heating or cuts that top flange, a lot of times we can come up with a repair for a top flange, but almost always when that bottom flange is cut or broken into, it usually means replacing the joist. I mean, sometimes under light loading we can do a repair, but it almost always means a replaced joist when that bottom flange is cut.
Yeah, and so what Craig means by replacing is, I mean, you don't have to remove the bad joist, but we talk about adding or sistering a joist right beside it. So that's our fix. For residential only, you can also header the joist off to the both adjacent joists around it. Let's say a plumbing drain that's cut the joist in half or something. And I do have some more slides coming up on holes and notches in joist. So another question I get asked a lot about I-joist, you know, is there an up and down? Does the writing matter? Today, we don't manufacture any of our I-joists with camber or anything. There is no top or bottom. It doesn't matter if the writing goes up or down. When we did talk about the flak jacket with that Generation 2 to meet IRC and the fire code, the flange that was coated, there was a top and a bottom. And today, I don't think there's any manufacturers that manufacture an I-joist with camber that have a top and a bottom. So it doesn't really matter. However, I'm always going to say, consult the manufacturer to confirm. In some of the commercial products that we used to manufacture, we did build camber to them, but they were more like trusses. But they were stamped top and bottom, and I always found it interesting to walk in the building and see top on the bottom of the joist, but it happens. Another thing that we come across a lot of times is damaged product, and it could be damage at the lumber dealer. It could be just in loading and unloading, a typical forklift stab like we see in the picture. And big thing to do is just make a call. See what our engineers and tech support say. And like I said, you can just go to the Weyerhaeuser website, click on tech support, and you can email these guys pictures and call them and everything. So another thing, if the joists aren't stored properly, they can take some bend to them. So we don't want never more than a ½ inch of change, and we always want them installed plumb. Next slide, Craig.
So we have a question here, as home inspectors, probably a pretty important one. What about prolonged moisture damage on the material from a leaking flange in plumbing that penetrates? Does that affect the adhesive and strength? Yeah, anytime wood gets wet, it definitely affects the strength of the product. And if that leak is there long enough, you're going to get deterioration in the wood fiber. You're going to get mold. So those areas you need to you need to take a real close look at that and make sure the integrity of the joist has not been affected.
Right, and that would be by a third party. A structural engineer would have to look at that. Some other misapplications that's possible in the field, we say the minimum bearing at the end of the joist is going to be 1 3/4 inches. The minimum bearing and intermediate support is double that. It's going to be 3.5 inches. So, but always consult the manufacturer. Next slide, Craig. Can I shift an I-joist? It really depends on what the subfloor is and the thickness of the span rating of subfloor. So, if it's space 19.2 or less, the framer can shift the joist if he's figuring out his plumbing layout up to 3 inches. It always works. If it's 3/4 inch subfloor, you'd have to be careful because it's only span rated on floors for 24 inches. So if the floor joists are spaced at 24 in center, they can't just shift the joist because then the floor sheathing will be overspanned. Next slide, Craig. So this would just be every market that I cover is different. So we have folks from all over the country, but how do you address parallel partitions that are going to be a plumbing wall? And what we say is, just put a joist on each side. We wouldn't want the framer to put both joists underneath a plumbing wall because we know when the plumber comes through, he's going to start cutting the flanges of the joist, and that's going to be a misapplication. So the framer, he's the guy that I would blame in doing the framing layout. He can figure out where a plumbing drop is from a toilet. It's going to be 12.5 inches to the. Pardon? Oh, I thought there was a question. Okay. So anyways, I blame that on the framer. So next slide, Craig. Just nailing the joist to the plate. It's just one nail, 1.5 inches from the end of the joist on each side of the flange. And I just went through this with a big home in the Catskills where, the homeowner called me up and he said, hey, my framer split the flanges. Are they supposed to do that? And I said, geez, can you take a picture, on your smartphone and text it to me? And the framer literally put 5 nails on each side of the flange of the web at the bearing and split the flanges entirely apart. And so there's no fix for something like that. I went out, verified it, took sent some pictures to our engineer. and they had to actually replace the entire floor system. There's no fix for some things. Next slide, Craig. You know, we get asked this question a lot too. With I-joist, do we have to install bridging? And if you go to our ICC ESR code evaluation report, it's 1153. We specifically state that bridging is not required for floor or roof TJI applications. So we don't like to see bridging installed because it creates squeaks. But it says right in our code report, bridging isn't required. And if you think of the idea of bridging, it's really for load sharing with dimensional lumber, where you have a big variation between one 2x10 and the next 2x10 because of knots and slope of grain. With I-joist, because we're manufactured, they're almost all the same strength, so we don't need that bridging for load sharing. Let's go to the next slide, Craig. And, you know, just as far as rim board installation goes, you know, it's got to be at least, the minimum is going to be 1 inch thick. I mean, we really like to see 1.125" or thicker for rim board. Years and years ago, we had some details, you know, when I-joist first came out, to use 3/4 plywood. And today, that, you know, but they had to do some special detailing at the corners and every 25 feet for lateral loads. Really, the wood I-joist industry doesn't support those details anymore. And we want to see a thicker rim board being used out there. So 1 inch is the minimum, 1.125" is preferred. If it's 1 inch, it has to be designed by a structural engineer for lateral loads. 1.125" or 1.25" is completely equivalent to solid sawn lumber for rim. So, you know, it's just one nail at the top and the bottom flange, and then the rim board has to be toe nailed to the sill plate every 6 inches on center with 10D nails. And that's a code requirement for transferring those lateral loads to the foundation. Next slide, Craig. You know, same thing. I said we can't use 3/4 plywood for rim or OSB. We don't want them using dimensional lumber either, because as you can see in this picture, you know, maybe that's a 9.5 inch I-joist with a 2x10, and there's a load-bearing wall on top of that that's supporting roof trusses. So all the load is going on the end of the I-joist, and the rim's not picking up those vertical loads. So essentially what's going to happen is it's just going to push the web right through the bottom flange, and we'll see failure. And, you know, I've even had guys in the field get creative and take 2x12s and rip them to the same depth, 9.5 inches. But the problem is 2x lumber shrinks. It's going to shrink 1/4 inch, so we don't want dimensional lumber for rim board. Next slide, Craig. Let's skip this one and try to get to meat and potatoes. We're starting to run out of time. So let's just talk about some things out in the field. Do blocking panels have to be installed? And really, if you look on the right-hand side, there's 5 cases where a blocking panel has to be installed. One is if there's a load-bearing wall below and a load-bearing wall above, we want to see a blocking panel, or it's the builder's option of squash block, and we're going to look at that in a minute. Next one would be to transfer floor diaphragm loads. You know, and typically that's going to be specified by the engineer of record. If you go to the next slide, Craig. And the other place that I see the blocking panels for the floor diaphragm is going to be with precast concrete panels, like Superior Walls up in the Northeast. They want to see the blocking panels installed in the first 3 bays for the floor diaphragm. And then number 3, if we go to the next slide, blocking panels are always required for cantilevered supports. Now, we let them cut holes in there for insulation and mechanicals, things like that. So there can be a hole in the blocking panel, but the end of every joist has to be laterally supported, so a cantilever gets a blocking panel for that. And then let's go to the next slide, Craig.
There is a question on cantilevers. Is there a standard for attaching decks to a cantilevered TJI floor system? I mean, are you getting at it something different than attaching a regular decking, or trying to figure out the question there, Russ?
Well, I think the question is can are there any if the full joists are cantilevered, the TJI joists, can I attach a deck to a cantilever joist? And honestly, I don't think I've ever seen that. So I would say.
I'm sorry. I thought they meant decking on top of the. So they're talking about an exterior deck to a cantilever joist. Okay.
Correct. Yeah.
Okay.
So there are no details on that. That has to be designed by a structural engineer.
Yep. Yep.
Yeah. So, another question.
Is the joist size for it? Wait a minute. We're getting no decks attached to a cantilever section. We have one reply. Joist cable. Same question. I think, if you consulted a structural engineer, if it was designed properly, you might be able to do that. But I would definitely consult a structural engineer on that one. We don't have any of those details.
No. In the last requirement for blocking panels is going to be if the joists were lapped in an intermediate bearing for whatever reason. Typically they're shipped long lengths, so we don't see lapped joists. But if it does occur, we want blocking panels because the end of any joist has to be laterally braced. And then number 5 is going to be possibly for draft stopping. So that's the blocking panels requirements. As far as squash blocks go, this can be used in lieu of blocking panels where there's a bearing wall below and a bearing wall above. We're trying to put that load around the I-joist at an intermediate bearing. And then number 2 is going to be to carry point loads from above squash blocks because we want to have that load path to the foundation. If you go to the next slide, Craig, we'll kind of see that concentrated load.
Hey, one thing I will point out real quick on squash blocks, just because I see it a lot. Sometimes you'll see squash blocks out at the rim board where the I-joist is at the rim, sitting on the plate. You don't need squash blocks out there unless they are handling a point load like we're going to show you in the next slide. But I do see that a lot, and if you see that, it's not necessary. It's not going to hurt anything. But it's just extra work that they don't really have to do.
Yeah, one of the reasons that we do layouts, so you can just, we call that a column support right there. Concentrated load above, and then it's transferred through the plate to a post below that takes the load to the foundation. And I think the next slide's a misapplication.
Ooh.
So we can see some concentrated loads from above that were not taken into account. And the one on the bottom, I guess, is that's a real field shot. You should see our 3-hour presentation. We showed a lot of misapplications, but, it's a masterful attempt at a squash block. So I think we're getting close on time, Craig. Probably let's go to the meat and potatoes. Yep.
Well, we got a question. Can squash blocks be just cut I-joist pieces? Blocking panels would be cut I-joist pieces. Squash blocks can be 2x material, dimensional material, or it could be engineered wood like TimberStrand or something like that you could use for squash blocks.
Yeah, exactly. And I'll see that from time to time. It's just more money. As far as joist hangers go, really the builders have 3 different types. I mean, they can use a face mount hanger or a top flange. And the only case that they have to put those web stiffeners in on the lower right-hand side, you see the 3 joists going into the beam, is if the side of the hanger doesn't touch the top flange, a web stiffener or a web filler is required. And then, more importantly, because I still run into it, is the correct nails should be used, joist hanger nails, and really just consult the joist hanger literature to make sure they're using the right nails. I still see today roofing nails being used, and was just on a job where they used screws from metal roofing to screw the hangers into a beam. So that's a no-no. They don't have the shear value of the nails, what that connection is designed for. So, and we still see hangers not being used where they pre-nail them up and don't put hangers on. That's a no-no. They have to have joist hangers, and it's got to be the correct model number. So I think for time, Craig, can we just jump to the I-joist holes? I think we've got a couple other slides here we'll skip over. And really, this is our biggest misapplication in the field is hole placement in an I-joist. So we don't want to cut the top or the bottom flange like Craig and I were saying. You know, the top flange, maybe we can fix it. If the flange gets damaged to the point that it gets into where the web meets the flange, the joist is pretty much shot. That means there's no repair at a joist. If it's just partial flange on that compression side, we can probably do a repair, but if it's on the bottom, that tension side, like Craig said, we probably can't do it. So as we're looking at this slide here, it says do not cut holes larger than 1.5 inches in the cantilever. And we can't cut holes in that hashed area that's right around the bearing. And so 1.5 inch hole can be cut anywhere outside of that hashed area. And then you can cut multiple holes, you know, in the joist, and really that 2 times, you know, you got D1 and L1, etc. We're going to find that round holes are more efficient, so typically round holes will be bigger in the web than square and rectangular holes, but you can cut both. Remember, workmanship is critical, so if they cut the holes bigger, you know, with a sawzall than they should, and I'm looking at an issue, I'm taking the whole cut there. Holes can be located anywhere in the web from top to bottom too. So if we're talking about a 4-inch hole, it doesn't necessarily have to go in the center of the joist, but we ask that they leave an 1/8 inch of web between the edge of the hole and the flange. So, and really the rule of thumb is cutting holes in the web. You know, you stay outside of that hashed area. You can cut 1.5 inch hole any place. And if you're cutting multiple holes, let's say a 2-inch hole and a 3-inch hole, we want to double the diameter of the largest hole. So we want 6 inches of uncut web between the holes. And that's a rule of thumb. You can cut multiple holes in the web as long as you meet edge distance from bearing, and we have enough web between the holes to meet that requirement. So there's really 2 requirements. Let's go to the next slide, Craig. And here's a typical hole chart, right? So, and I don't know how well everybody can see it, but we've picked out 11 7/8. Let's go 230 series. And if you're looking at the top of the page, we've got round hole size, rectangular hole size. And for 11 7/8 230, if I wanted to cut a 3-inch round hole, it has to be a minimum of 1'6" from the inside of the bearing to the edge of the hole. That's my minimum distance. And if you look a little further, if I want to cut a 4-inch round hole, I've got to go to 2 foot away from the bearing. So larger the hole, further from the bearing point. If we had that.
Russ, you're fading in and out. Russ, we lost you. Well, can everyone still hear me?
Yeah, Craig, we can hear you. Can you take it over from here?
Yeah, I mean we're pretty much close to wrapping it up. We've gone our hour anywhere here, but just to, you know, if you guys see something like this, that's a red flag for you. This guy got a little bit carried away. You know, you might been able to run those through the joist, but you would have had to separate those individual holes rather than cutting one big hole like you see there. Here's another one here. You know, they've done this. You know, maybe a better way to do this would have been maybe some 3 or 4-inch holes separated properly with multiple lines running through there. And then again, don't notch the flange like you see in this picture here.